Hello friends, today we are going to learn brute force approach, that is exhaustive search. In earlier session what you have studied, that is called brute force approach, right? Now we are going with exhaustive search. Now what is exhaustive search here? It is like we are going to find all combinatorial combinations. Basically, what are the all alternative possibilities we have? As I said you, that brute force technique is what? A straightforward approach to solve the problem, right? So maybe we are able to solve the problems. It will take it will take more amount of time to solve it because of exhaustive search. We are going to find all permutation combination. Whatever the possibilities we are having it, we are going to explore all the possibilities, and among that we are going to select what is the best solutions or feasible solutions. If you are looking for the optimal solutions, then what is the best solutions we are going to find in all alternative. It means when you are solving the problems, you should have all the solutions in your hand, right? Like in other methods, whether applying dynamic programmings and all, we are looking for the optimal solutions. We'll have only one solutions, divide and conquer optimal solutions, right? Dynamic programming will give optimal solutions. So we are not looking for all the possible solutions or feasible solutions. So let us see that in exhaustive search how you are going to perform the task. As I said you that it is basically based on the combinatorics, right? We are going to find all the combinations. In this particular topic, we are going to learn two different algorithms, right? One is traveling salesperson, that is a problem, or you can say that postman problem, traveling salesperson's problem, traveling salesman problems, all are same. So we are going to discuss by using exhaustive search, right? Second is knapsack problem. So let us see that what is TSP. In traveling salesperson problem, look, there are, say, n is equal to 4, right? It means there are number of cities. We can say that number of cities is 4, and path connecting all the cities, you can say that edge, right? So we will have multiple edges, multiple path. So say, as for example, if you have A city, B city, C city and D, right? And we have connectivity. We have connectivity between all these cities, right? And we have diagonal connectivities as well. So what will happen if this is the case? Say here is 3, here is 4, here is 7, 1, 4, 6. So these 1, 4, 6, 3, 4, these all are the weight. So you are going to convert this into the weighted matrix, right? That is called cost matrix for the given connected weighted graph is required for input to this problems. Now, what is a traveling salesperson's tendency will be there, or postman tendency? Traveling salesperson will have tendency to start the journey from one place by visiting all the cities exactly once and come back to the same cities, right? When you are going to start the journey from the city A, we have to visit all remaining cities B, C, D exactly once and come back to A, if A is a source, right? Likely, if postman will start the journey from the post office, he has to visit all the homes exactly once to drop the letters and come back to the post office to report back, right? So that is called traveling salesperson's problem. Remember that we are not going to repeat any vertex. We are not going to repeat any intermediate vertex. Which vertex are we going to repeat? Only source vertex from where journey started. So in this particular case, if you see that if you are going to start from A, right, remaining all we are having B, C, D, right? So B, C, D, there are 3 different cities, and I just showed you that we have to return back to city A. Then how many different permutations will be there? How many different paths? It can be A, B, C, D, A, or it can be A, B, D, C, A, right? Or it can be A, C, D, B, A, or A, D, C, B, A, like this, A, D, B, C, A, like this we have many combinations. So how many such combinations will be there? You are already studied permutations combinations. If you are starting this journey from A, and again you have to reach back to A, in intermediate vertex, what are the vertex we have? B we have, C we have, D, and return back to A. So how many such combinations will be there? These all intermediate vertex can be arranged, right, in 3 factorial different ways. How many elements? B, C, D, 3 elements. So 3 factorial, 6 different path will get it. So what are that another path? We can write A to B to D to C and A. Similarly, A to C to B, D, A. A to C, D, B, A. A to D to B to C to A. A to D to C to B, A. So I just showed you that B, C, D, these 3 vertex can be arranged in 6 different ways. So because of this, we are getting 6 different paths. I just showed you that exhaustive search, we are going to find all possible way based on the permutation and combinations, right? So now to find the what will be the cost for the traveling salesperson or salesman to reach to the starting cities. What will be the cost? A to B, if you see the distance is 3 plus B to C is a 4 plus C to D is a 7 plus D to A is 1. So what is total? 1 plus 7, 8 plus 4, 12 plus 3, 15. Right? Similarly, A to B is 3, B to D is 6, D to C is 7 plus C to A is 4. Now for third path, A to C is 4, C to B is 4, B to D is 6 and D to A is 1. It's 15. A to C is 4, C to D is 7, D to B is 6 and B to A is 3. 20. A to D is 1, D to B is 6, B to C is 4 and C to A is 4. 15. Similarly, A to D is 1, D to C is 7, C to B is 4 and B to A is 3. 15. So among these you can see that there are paths as giving shortest total cost is 20. There are path is giving total cost of the path is 15. So path length is, suppose it is a cost, so total cost to travel from A to A via B, C, D is a 15, 20, 15, 20. Generally this path will give you in the pair if it is undirected graph. Now after that we realize that minimum cost is 15 and these all are the solutions is giving you 15, right? So these all are considered to be the feasible solutions if you are getting 15. If values are 20, it's not necessary that we'll get 15 4 times or 22 times. It can be reversed, but we have to find feasible solutions or best solutions after writing all the path, after doing all the iterations, after doing all the permutations. So here number of cities was 4. Think of if number of cities are more, number of vertex are more. If it is 10 vertex, right? And as you see the number of cities are 4, then remaining 3 vertex, 4 minus 1. We have done the factorial and 6 different paths you got it. If number of city is n, total number of city is n, then how many possibilities is there? Total path, total number of path, total number of traveling salesperson problem path is n minus 1 factorial. N minus 1 factorial. It is in order of growth. Please recall, in order of growth, factorial is having highest order of growth, right? And we are getting here n minus 1 factorial in a case of salesperson's problem, traveling salesperson's problem. It is the highest time complexity. It will take more time to perform the task. If number of cities is less, yes, it will take lesser time. But if number of vertex are more, then it has to be entered in factorial time complexity n minus 1. Here also factorial, but it is lesser values. 3 factorial is 6 times, right? And here, if number of cities are 10, number of cities 10, so 10 minus 1, it is 9 factorial. It is very large values, right? So that many number of iterations is not possible to write it. Yes, I hope you understood this. And this is called it as a time complexity for traveling salesperson problem is what? N minus 1 factorial. Yeah. Similarly, next is knapsack problem. What is knapsack? Knapsack is a container. What is knapsack? It is a container, or you can say that bag. Look, knapsack problem is when number of item is given, right? Number of item is given, their weight of the item is given, and profit is given. Weight of item is given and profit is given. So say number of item is given like 1, 2, 3, 4. Weight of the item is given 2, 1, 3, 2. And profit is 12, 10, 20, 15. 12, 10, 20, 15. Now, what is exactly knapsack problem is? We have to find combination of items such a way that we can generate maximum profit. Say, here we have total weight is given and capacity of the bag. Capacity of the bag, you can say that it is a 5 kg. So this is the weight and say that capacity of bag is 5. So maximum 5 kg combinations you can put it in that bag. And in order to maximize our profit should be the maximum. So how many different possibilities we can have it, right? Remember that one item to increase the profit, suppose third item is having profit 20, to increase the profit only 3 we are not going to repeat it. Each and every element has to be selected maximum of 1 time, right? If you are selecting, right? But it's not necessary that you have to select all the items. You have to select the items based on the given capacity. So maximum capacity of the bag, maximum you can select the item such a way that it should not increase more than 5. Second things, we are not going to select the fractional weight from any of the item. Here either you are going to select the complete item or you are not going to select the items for the bag. Say here you have 3 plus 2 is 5 kg. This can be one profit 35. This can be 2 plus 3 is 5 kg. 20 plus 12 is 32. So here if you first and third item 32, third and fourth item 35. 35 is more. But there is a chance we will select another possibilities and we can increase the total profit for the person. right? So that is basically knapsack problem here, right? How smartly you're going to select the items such a way that it will be give you maximum profit. Since it is exhaustive search, we are going with all the possible combinations, and finally we are going to decide which is the best. So how many items you are having, friend? It is 4 items. So we are going to find total possibilities is 2 to the power 4. So sorry, 2 to the power 4, we are going to select all possibilities, right? As you have studied power set, right? So we will be having all possible combinations of set. So say that first, if you are going to select items, right, and their profit, you are going to write it, and whether it is feasible or not feasible, right, that will write as a comment. So if you are going to select the only first item, what is the profit of first item? It is weight is 2 and profit is 12. So this is 1. If you are going to select the second item, weight is 1, profit is 10. If you are going to select only 3 items, weight is 3, profit is 20. If you are going to select fourth item, weight is 2, profit is 15. So these all can be accommodated in capacity. One item, only one item. Now next is we are going with combinations. Combination means what? 1 and 2. 1 and 2, if you combine 2 plus 1, what is the total weight? 2 plus 1 is 3 less than 5. What is the profit? 12 plus 10 is 22. Similarly, we can go with 1 and 3. We will go 1 and 3. Total weight is 2 plus 3. 5 kg. It is equal, no problem. And profit is 12 plus 20. 32. So among these, 32 is maximum. Similarly, we can go with 1 and 4. 1 and 4. Total weight is 2 plus 2. 4 kg. No problem. And total profit is 12 plus 15 is 27. Similarly, with 1 combination is over, with the 2 we can see that 2 and 1 we cannot do, 2 and 1 is done. So 2 and 3, we will combine 2 and 3, total weight is 1 plus 3, 4 kg, no problem, and profit is 10 plus 20, 30. Similarly, we have a 2 and 4. 2 and 4. What is total weight? For the bag is 1 plus 2 and total profit is 10 plus 15 is 25. So now we have one more combinations called 3 and 4. We will combine 3 and 4. Total weight is 3 plus 2, 5 kg, no problem. And profit is 20 plus 15 is 35. It is 35. Right? So among this you can see that till here 35 is maximum. Is it the final solutions? No. We can go with combination of 3. So we will go in combination of 3. Can we do 1, 2, 3? 1, 2, 3 combination of 3 elements? 1, 2, 3. What is the weight? 2 plus 1, 3 plus 3, 6. No, not possible. 1, 2, 3. So weight is 2 plus 1 plus 3. It is not feasible. Not feasible. Rejected. Why is it rejected? Reason is total weight is more than the capacity of the bag. Total weight of the item is more than the capacity of the bag. Similarly, if we will go and take the another combination, 1, 2, 3 is over, we can go maybe 1 to 4. 1 to 4 item, 1, 2, 4. 2 plus 1, 2 plus 1 plus 2. 5 kg, no problem. 12 plus 10, we are having 12 plus 10 plus 15 is 37. So no problem. 2 plus 1 plus 2, 5 kg capacity. Profit is 37. So one combination over. Now there is a chances we can go with 2, 3, 4. 2, 3, 4. So what is the total weight? 1 plus 3 plus 2. Not feasible. Reason is weight of the bag is increases. So hence we are not able to accommodate. So how many possibilities we have checked? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? 13 case. What is next? We can have combination of 1, 2, 3, 4. All items. All items. Right? If you consider all items, it is not feasible. There is one more chance. 1, 2, 1, 3, 4. Also you can check. 1, 3, 4. 1, 3, 4. It is not possible. Cancel. So total 15. And one is, if you are not going to select any item, 5. Not going to select any item. So what is the profit? Profit is 0. So among these, what is the maximum profit? Maximum profit is given by these combinations when element 1, element 2 and element 4 is selected. How we came to know? After doing all permutations and combinations, all possible solutions, we are able to find maximum profit is 37. That is comes under exhaustive search knapsack problem. So that is why we have to do by seeing that number of items. First you have to find how many different subsets we need to check. 2 to the power number of items. So 16 possibilities. We have checked with all the 16 possibilities and finally we come to conclusion that 37 is maximum profit for this given knapsack problem. Now, so what will be the time complexity, friend? Time complexity of this algorithm is going to be time complexity of knapsack, that is using exhaustive search. Exhaustive search is 2 to the power n. T of n is equal to theta of 2 power n is a time complexity. Okay, theta of 2 power n. Just now we have seen that all possible solutions 2 power n. So theta of 2 power n. You are telling salesperson problem to find minimum path, shortest path for the traveling salespersons. What would be the proper path from source to source by visiting all other vertex, intermediate vertex exactly once. So basically we are going to find out the shortest path for traveling salesperson, right? And as we have discussed that time complexity of this salesperson's problem is theta of n minus 1 factorial. Okay, n minus 1 factorial. And knapsack problem time complexity is going to be T of n is equal to 2 power n, theta of 2 power n. Okay, so one is factorial, that is the last time complexity in order of growth or basic efficiency class, and 2 power n is second last column. So both is giving you higher time complexity, maximum time complexity. So that is why we can conclude that exhaustive search or brute force technique or exhaustive search technique used to take maximum time to perform the task to find the solutions. Thank you.